Have you ever found yourself gazing up at the sky, pondering the celestial phenomena that unfold above us? Today we embark on a journey to explore one of the most mesmerizing spectacles known to humankind, the eclipse. Imagine standing beneath the vast expanse of the sky, witnessing as the sun, our radiant star, is gradually obscured by the graceful movement of the moon. It's a moment that evokes sheer wonder and amazement. But let's rewind the clock and delve into the annals of history. Millennia ago, our ancestors viewed eclipses through the lens of mythology and mysticism. To them, an eclipse was more than just a celestial event. It was a cosmic battle, a clash between celestial forces that held sway over their lives and destinies. There are 4 distinct types of solar eclipses: total, partial, annular, and hybrid. But the type you witness depends on both the moon's position and your location on Earth. During a total solar eclipse, the sun, moon, and Earth align perfectly, with the moon obscuring the entirety of the sun's disk. However, to witness this awe-inspiring event, you must be positioned within the path of the shadow cast by the moon. In the case where the alignment isn't precise and the moon only partially covers the sun's disk, a partial solar eclipse occurs. This phenomenon is observable even if you are outside the direct path of the moon's shadow. An annular solar eclipse occurs when the sun, moon, and Earth align, but the moon is slightly farther away than usual, appearing smaller in relation to the sun. Consequently, the moon doesn't entirely cover the sun's disk, resulting in a striking ring of fire effect. Hybrid eclipses are exceptionally rare occurrences, requiring precise conditions. They happen when the moon is at just the right distance from Earth. The curvature of the Earth's surface causes observers at the beginning and end of the eclipse path to be slightly farther from the moon than those in the middle. Consequently, those at the start and end points see an annular eclipse, while observers in the middle experience a total eclipse, making hybrid eclipses a unique and captivating spectacle. While each eclipse may seem entirely unique, the truth is they follow a predictable pattern. Solar and lunar eclipses recur every 18 years, a period known as the Saros cycle, which spans approximately 6,585.3 days. The only variation lies in the geographical visibility of the eclipse from Earth. For instance, consider the solar eclipse that marked the end of the 20th century on August 11, 1999. Its path of totality extended from west to east across Europe and Asia. Fast forward 18 years and 10 days to August 21, 2017, and the same eclipse reoccurred. But this time, its path of totality traversed North America, stretching from the Pacific to the Atlantic. The discovery of this cycle dates back over 2 millennia to the Babylonians, who first observed its recurrence. However, it was British astronomer Sir Edmund Halley, renowned for predicting the return of the comet that bears his name, who officially named it the Saros cycle in the late 17th century. Total solar eclipses are indeed not visible everywhere, unlike lunar eclipses, which can be seen anywhere the moon is above the horizon. During a lunar eclipse, the moon passes through the Earth's shadow in space, resulting in its darker appearance. If the moon is visible during this time, you'll witness it undergoing its eclipse. However, the scenario is quite different during a solar eclipse. Here, the moon moves between the Earth and the sun. Yet due to the moon's smaller size compared to both celestial bodies, its shadow does not cover the entire surface of the Earth. As the moon orbits the Earth, its shadow moves across the Earth's surface, Consequently, only a relatively small portion of the Earth's population falls within the path of the moon's shadow and gets to witness the phenomenon of a total solar eclipse. During a total solar eclipse, the entire event typically spans a little over 2.5 hours and progresses through 4 distinct stages. The first stage, known as first contact, occurs when the leading edge of the moon makes initial contact with the leading edge of the sun. This marks the beginning of the partial phase of the eclipse. Over the next 75 minutes or so, the moon gradually moves across the face of the sun until its trailing edge touches the leading edge of the sun. This pivotal moment, referred to as second contact, signals the onset of the totality phase, where the sun is completely obscured by the moon. As the eclipse progresses, the leading edge of the moon eventually touches the trailing edge of the sun, signaling the end of totality and the beginning of the second partial phase. This stage is known as third contact. Finally, fourth contact occurs when the trailing edge of the moon meets the trailing edge of the sun. At this point, no part of the moon's disk is overlapping with the sun's, and the eclipse concludes. Indeed, one of the most awe-inspiring phenomena during a total solar eclipse is the transformation of day into night. We're all familiar with the fact that stars become visible when the sun sets and the sky darkens. Normally, during the day, the sky appears bright blue due to sunlight being scattered by molecules in our atmosphere. This scattering is most pronounced for blue light, which has the shortest wavelength among visible colors. However, during a total solar eclipse, the moon moves between the Earth and the sun, blocking the sunlight. As a result, the sky darkens, akin to twilight or dusk. Suddenly, stars that are typically obscured by the sun's brilliance become visible, along with any planets that might be above the horizon. This celestial spectacle is often accompanied by a sense of wonder and awe. The sudden darkness during totality also has a profound effect on local wildlife. Birds return to their nests, insects may become silent, and the temperature can noticeably drop. All around, observers find themselves enveloped in an eerie, silent darkness, broken only by the gasps of spectators awestruck by the spectacle unfolding above. The duration of totality during a total solar eclipse varies with each event, influenced by factors such as the specific circumstances of the eclipse and your location on Earth. While some eclipses may offer longer durations of totality, none exceed 7 minutes and 32 seconds, with such lengthy eclipses being rare occurrences. For instance, the last total solar eclipse lasting over 7 minutes took place on June 30th, 1973, and the next is anticipated on July 27th, 2204. Moreover, the length of totality is contingent upon your position along the path of the moon's shadow. Standing precisely halfway along the eclipse's path, at the center of the shadow, grants you the longest possible duration of totality for that particular event. Conversely, as you move away from this midpoint and toward the edges of the shadow, the duration of totality diminishes. If you find yourself near the edge of the moon's shadow, the period of totality might last only a few fleeting seconds. Thus, your location within the eclipse's path significantly influences the duration of this remarkable celestial event.